Determine the key characteristics and then graph f of x equals the quantity 3x squared minus 27 divided by the quantity 8x squared minus 8x minus 6. Let's begin by factoring the numerator and denominator. In the numerator, the greatest common factor is 3. 3x squared minus 27 equals 3 times the quantity x squared minus 9. In the denominator, there's a common factor of 2, giving us 2 times the quantity 4x squared minus 4x minus 3. And now see if we can factor further. X squared minus 9 is a difference of squares. X squared minus 9 is equal to the quantity x plus 3 times the quantity x minus 3. And now see if we can factor 4x squared minus 4x minus 3. Because of the 4x squared, this is more challenging to factor. Because the first term is 4x squared, let's try factors of 2x and 2x in the first positions. And now we want to select factors of negative 3 for the second positions so that the sum of the inner and outer products is equal to negative 4x. If we put a minus 3 here and a plus 1 here, the outer product is negative 6x, the inner product is positive 2x, and the sum is negative 4x. Let's go ahead and write the rational function in factored form above. And that's where we're going to determine the key characteristics. First, the domain is a set of all possible inputs, or x values. And because division by 0 is undefined, we must exclude the x values where we have division by 0, which is where the denominator is equal to 0. The denominator equals 0 when 2x plus 1 equals 0, or when 2x minus 3 equals 0. Solving for x, in the first equation we subtract 1 and divide by 2, giving us x equals negative 1/2. For the second equation we add 3 and divide by 2, which gives us x equals 3/2. The domain is all real numbers except negative 1/2 and 3/2, which indicates, using interval notation, the domain would be the open interval from negative infinity to negative 1/2, union the open interval from negative 1/2 to 3/2, union the open interval from 3/2 to infinity. And now let's talk about the holes in vertical asymptotes. We don't have any holes because there are no common factors between the numerator and denominator. The holes are the zeros of the denominator. They're also zeros of the numerator. So we'll say no holes or none. The vertical asymptotes are the zeros of the denominator that are not zeros of the numerator. We already know x equals negative 1/2 and x equals 3/2 are the zeros of the denominator that are not zeros of the numerator, and therefore these two equations are also the vertical asymptotes. And we do want to give them as equations because they are vertical lines. And now let's determine the y-intercept. The y-intercept is where the graph crosses the y-axis. Every point on the y-axis has an x value of 0, which means to determine the y-intercept, we determine f of 0. Let's go ahead and find f of 0 in the original form. Subbing in 0 for x, we can see f of 0 equals negative 27 divided by negative 6, which simplifies to positive 9/2. We can divide the numerator and denominator by negative 3 to get 9/2. This indicates the y-intercept is 0, 9/2. And now we'll determine the x-intercepts, which are the x values for which the function value is equal to 0. A fraction is equal to 0 when the numerator is 0 and the denominator is non-zero, which means to determine the x-intercepts, we need to determine the zeros of the numerator. Well, x plus 3 is equal to 0 when x equals negative 3. Negative 3 comma 0 is an x-intercept. X minus 3 is equal to 0 when x equals positive 3. 3 comma 0 is an x-intercept. Notice when x equals positive 3 or negative 3, the numerator is 0, the denominator is non-zero, and therefore the function value is equal to 0. And finally, we'll determine the horizontal asymptote. There's several ways we can do this. The quickest, easiest way is to look at the degree of the numerator and denominator. If the degrees are the same, which is in our case, the horizontal asymptote is equal to the ratio of the leading coefficients, which in this case would be 3 divided by 8 or 3/8, indicating y equals 3/8 is the horizontal asymptote. If the degree of the denominator is greater than the degree of the numerator, the horizontal asymptote is y equals 0, because the function values approach 0 as x approaches positive or negative infinity. And if the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote, because as x approaches positive or negative infinity, the function values increase or decrease without bound. And now let's graph the rational function. Let's begin by graphing the vertical asymptotes of x equals negative 1/2 and x equals 3/2 or x equals 1.5. Let's go ahead and plot the y-intercept of 0, 9/2 or 0, 4.5. Should be here. The x-intercepts are negative 3, 0 and 3, 0. The horizontal asymptote is y equals 3/8, which is y equals 0.375, which should be approximately here. And now we could find some additional points, but let's go ahead and sketch the rational function using just these 3 points. We know there will be 3 pieces, and each piece will pass through the given points and approach the horizontal and vertical asymptotes, which indicates on the left the graph would look something like this. On the right, the graph would look something like this. The only real unknown is this middle piece. We don't know how far down it comes before it turns and approaches the vertical line, x equals 3/2. It does go down a little bit past the y-intercept and looks something like this. Again, we could find some function values between x equals 0 and x equals 1, but we'll go ahead and leave it like this. I hope you found this helpful.